Hi, this is Ken, and welcome back to our lesson. We're still on units physical quantities and vectors, and now we are going to continue with our discussion starting with your vector quantities. But before everything else, I have here a trivia on how an MRI works. So your MRI, which stands for your magnetic resonance imaging. Okay. So the human body is made of water. Water, so meaning you have your H2O molecules. So your H2 molecules contain hydrogen nuclei or photons, which become aligned in a magnetic field of around 0.2 to 3 teslas, which align the proton spins. So as the magnetic field of the MRI is turned on, the protons in your nuclei moves, okay, like arrows, and it spins. Okay. The MRI also produces a radio frequency current that creates a varying magnetic field. The protons absorb the energy from the magnetic field and fix their spin. When the field is turned off, the protons process returning to their normal spin that produces a radio signal that can be measured by the receiver and made into an image. So basically, your magnetic field and the directions of your protons, or how your protons line up, can actually be represented by your vectors, which are what we're going to discuss in the next slides. So in physics, we have two types of quantities. These are your scalar quantity and your vector quantities. So what are these things? So when we say scalar quantity, these are quantities which can be described by a single number. Like say for example, you have 2 kilometers or 7 inches or 250 newtons or 5 meters per second. So these are some examples of your scalar quantity. On the other hand, your vector quantities are quantities which have both a magnitude and direction in space. So when we say magnitude, that means you have your number, and when we say direction, uh, you can your direction may either be like your geographic locations in space. I think you're familiar with um, your north, your east, then your west and south. Okay. So in our class, a vector quantity is represented by a boldface italic type with an arrow over it. Okay, we will represent our vectors like this one here. You have your boldface letter and then an arrow on top. Okay. Some books they use uh, a bold letter for a vector. I've also seen books wherein you have your letter and then a line below. So when you see something like this, you have your vector quantity. But here in our class, we're going to simply use a capital letter and then you have an arrow on top. Okay, so that those are your those are our symbols for your vector. And again, we are going to use this symbol here for our class. The magnitude of your vector A is written as A, just your simple letter A, or it can also be written as your vector A with the absolute value of your vector A. So you enclose your vector with two parallel lines to um, signify that you want, or that you're referring to the magnitude of your vector quantity. In most cases, we are going to draw your vectors in space to help us visualize how your vectors are moving around, or this will also help us in our analysis or in our calculations later on. And how are we going to draw your vectors? So in drawing your vectors, you just draw a vector as a line with an arrowhead at its tip. So it's just a simple straight line with an arrowhead on top. Okay? The length of the line shows the vector's magnitude. If I have these two vectors here, let's see, this is your vector A, and then I have another vector, vector B. Okay. looking at these two vectors here, we can say that vector B is, or vector B has actually a greater magnitude than your vector A. By simply looking at your drawings, the length of your vector um, B is longer than your vector A. Okay. The direction of the line also shows your vector's direction. If we're going to refer into your directions as your north, east, your west, and then your south, if I draw a vector here, that means that this vector points to the north. If I draw a vector um, like this, that means your vector is in between your north and then your west direction. So that means your vector is in the northwest part, or in the second quadrant of your x and y axis. Okay, again, the length of the line shows the vector's magnitude, and then the direction of the line shows your vector direction. Let's have another example. Okay. Okay, again, this is your north, east, and then your west, and then your south. If I have this vector here, okay, and then this is at 30 degrees, and let's say this is 5 meters, sorry, this is at 5 meters. So, and let's say this is your vector D. So that means here, your vector D is 5 meters, 30 degrees north of east. Okay. Oh, sorry, let me remove this one. So you have your vector D is 5 meters, 30 degrees north of east. For the benefit of some of the students who find it confusing to read geographic locations, let us have a review here of your of reading geographic locations in space. So you are now familiar with your north, which is pointing on your positive y-axis, and then your south down your negative y-axis, your east on the positive x-axis, and then your west on your negative x-axis. Okay, so those are your north, east, west, and south. But what if I have a um, what if I have a direction on here, and then let's say this is at 45 degrees. Okay, so if this is at 45 degrees, you simply read this one as your northeast. So that is your northeast. Okay. If you have, on the other hand, here, still at 45 degrees, this is your northwest. Here, 45 degrees, this is your southwest. And then here, 45 degrees, this is your southeast. So all the directions that are at 45 degrees or at the center between your northeast or your northwest, okay, if they are located or if they are at angle of 45 degrees, you read them as your northeast, your northwest, your southwest, and then your southeast. Remember that the angle between uh, these two lines here is at 90 degrees. So these directions are at the middle of your quadrants. Okay. Again, you have your northeast, your northwest, your southwest, and your southeast. Your northeast, northwest, southwest, and southeast are easy because they are just at 45 degrees in your quadrants. But take note that it is not always, or your angles are not always at 45 degrees. Say for example, you have this vector here, okay? And then let's say that this angle here from east to north is at 30 degrees. So how are you going to read the direction for this vector? Okay. As you have observed, I have also drawn an arrowhead for your vector to tell us that the angle is measured from east to north. So if you have this vector here, you're going to read the direction for this one as 30 degrees north of east because it is measured from your east towards your north. Okay, so that is the north of your east side. Another example is, let's say, draw this vector here, okay, and we have this angle here. Let's say this is at 50 degrees. Okay, how are you going to read this one? So your angle is measured from your west towards your south, that is at 50 degrees. So the direction for this one is read as 50 degrees south of west. Okay. If instead, going back to our first example, the angle is measured from the north towards your east, as represented by the arrowhead, and this is at 60 degrees. You read the direction for this vector as 60 degrees east of north. So the arrow directions are also important in the reading of your geographic locations in your space. In the next video, we're going to discuss on how you're going to add your vectors. Okay, we are going to discuss the two ways of addition of vectors. First, we have your graphical method, which we're going to talk about your head to tail method, and then your parallelogram method. And then we're also going to discuss your analytical method on addition of vectors.